So, calculus students, let's do these practice AP problems in preparation for your test. It's the minimum you should be doing. You should be understanding how to do every single problem, but you should also redo all of your quizzes as well in preparation for your test. Go into the Unit 2 folder, print out blank copies of the quizzes, do them. So, in this unit, we talk about slopes are rates of change. An average rate of change is a slope of a secant line. Instantaneous rate of change is a slope of a tangent line. We started with average rate of change, just using the slope formula. So if you're asked to find the average rate of change, you just need the two y coordinates at these two x coordinates, and then you use your slope formula, which is the average rate of change over the interval, which is your classic y2 minus y1, x2 minus x1. You don't have a calculator, so you have to do this by hand. 3 to the 4th, 3, 9, 27, 81 minus 15, which is 7166. Yep. And then 0 is 0. That's nice. So y2 minus y1 over x2 minus x1. 3366 over 3 is 22. So I'm selecting C. Number 2, we had piecewise functions. Out of all of your quizzes, make sure you know how to do lesson 2. Lesson 2, very important. It really covers every single problem, just in the most basic ways with just using the power rule. And we talked about being differentiable. Differentiable means you're continuous and there's no sharp points. I'm testing both of these because the answer choices are either you're continuous but not differentiable, you're differentiable but not continuous. This can't happen. If you're differentiable, you must be continuous. Neither continuous, that means you're not differentiable. Both continuous and differentiable. To check continuity, you just want to make sure that the two pieces meet up, where we leave one and we pick up the other one, making sure there's not a jump. Get 9 equals 18 minus 9. So that checks out. So we are continuous. Let's check to see if there's no sharp point. So when they meet up, will they meet up at a sharp point or not? So we check the tangent slopes. Now, this is when we introduce the concept of a tangent slope generator and how we can find the equation that will, its y coordinates give us the tangent slopes of the original equation. So like f prime of 1 is the tangent slope generator for little f1. So 2x will generate the tangent slopes of x squared. I'm able to plug in 3 and get 6. F little 2's derivative is just 6. It's 6 minus 0. The derivative of 6x is 6. The derivative of 9 is 0. I can't plug in 3 anywhere, so it's just 6. So these guys meet up so that their slopes are 6 at the same time. So they meet up, but in such a way so that their slopes are the same. So we are continuous. We don't have a sharp point, so we're continuous and differentiable. Okay, first question that involves a equation of a tangent line. Okay, so maybe it's important to make sure we understand the visualization of things. We have some cubic, and we want, I don't know if this is correct right now, but like at -1, I want the equation of that line. What do you need for an equation of a line? Well, you need a point and a slope to go into this point slope form of a line. Now, the point is the point that passes through the function f. The slope, we don't know. But to find the slope, we need the tangent slope generator. Now, you should be able to visualize tangent slopes. You'll be asked to sketch what f prime would look like for an f. and it looks like it's positive 0, negative 0, positive. So I don't know exactly what it's going to look like, but something maybe like this, maybe shifted. And this y coordinate, wherever the y coordinate is in -1, I think it's a negative, I'm not sure. Whatever that y coordinate is, that's going to be the slope value. Now, we found in lesson 1 that there's an equation for this. And we use rules to find the equation. The rules come from our knowledge of the combination of a limit and a slope formula. And then smart people use that formula to develop the rules. And we find out that 12x squared minus 5 is this equation for f prime. Now, plugging in -1 gives me the slope. Now, that's 12 minus 5, so it turns out it's going to be positive 7. So, this graph is wrong, like my slope is positive, but whatever. That's the slope. That's m. That's the slope of f at x equals -1. It's very, very important to understand, like, what do you get when you have f prime and how do you use it? It's a tangent slope generator. It generates tangent slopes. The other thing I need is the point that the line passes through. So this is when we go and plug in -1 into the original equation. -1 cubed is -1 times 4 is -4. -1 times 5 is -5, but it's minus. So that'd be like a plus. So it's like -5 times -1. And we find that f of -1 is 4. So in reality, what we have here is maybe something more like this, where here, the point right there is -1, 4, and the slope there is 7. So we plug that information into this point slope form of an equation. X minus x1, x minus -1, x plus 1. Now you look over here, you notice, oh, I don't have any of those. Oh no. Panic? No. For your test, it's multiple choice. You may have to take your answer and simplify it. This would be a situation where we need to simplify. Don't think you did something wrong. Just try to do a little bit more to your answer to get an answer that you see. I distribute the 7, I add the 4. This turns into y equals 7x plus 7 plus 4 is 11. So that's why I'm choosing C. This is a tough problem. We actually kind of skipped this in our notes. I want to show you it just so maybe you can kind of figure it out. There's this line y equals -x plus k. It is tangent to the graph of y equals x squared plus 3x plus 1. Now, when you are tangent, there are things that happen. Like here is maybe this line, -x plus k. It's -x plus k, so it's going to have a negative slope. But like what you need to do is like kind of set up equations so that we can find k. And how do we set up equations? Well, what is the things that are shared? There's a point that this line and this function share. And the slope of this line and the tangent slope are shared. So that's what I'm gonna work with. The fact that there's a shared point. So the y's will equal each other, which gives me this equation. And the other thing that they shared is a slope. This is similar to like finding when we have a tangent line parallel to some other line. And you're like, oh, what's the slope of my line? That's the slope of the tangent I'm looking for. Slope of this line is -1. Well, when will this equation have a slope that equals -1? Well, I can take the derivative to find the tangent slope generator. And this is one of the situations where I'm going to see when will my tangent slope generator generate a certain slope? When will my tangent slope generator generate a slope of -1? So I set these two things equal to each other. This enables me to solve for x, and then I'll be able to solve for k. So I subtract 3, I divide by 2, I get x is -2, -4 plus 3. And then I plug that back into here, and I'm going to be able to solve for k. Plugging in -2, it's negative x, so negative -2 is +2. -2 squared is 4. So I get 2 plus k equals -1. K equals -3. Okay? And if you wanted to check, like, if you have a calculator, you can go ahead and my thing froze. Okay. You can go ahead and like graph this equation and graph this, and see that it's going to be tangent. And maybe let's. I'm not going to do that because you are not going to be able to do it on the test. You just have to trust that you're doing things correctly. All right. What's the equation for the tangent to this? All right. So I have to find the tangent slope generator, and I'm going to have to find the point. Let's find the point first. So, you want an equation of a tangent line, you need the equation of a line. Point, slope. Slope comes from the tangent slope generator, point comes from the function. So plugging in 1 into the function will give me 1 to the 5th times 2, which is 2. So I have the point 1, 2. At the point 1, 2, what's the slope? Well, we need the tangent slope generator. Okay. This one is a little tricky because you see this chain, this composition, but you also see a product. What you'll have to do is use the product rule, and inside the product rule, when you're taking the derivative of the first, you got to use your O and your I. So the derivative of the first will be 5 parentheses to the 4th times 2. So I'm going to write that down. I'm going to fill in the parentheses. 5 parentheses 4th times 2. What starts in the parentheses, stay in the parentheses. That's the derivative of the first. Times the second, plus the derivative of the second, which is just 1. Derivative of x plus 1 is just 1, times the first. This is the tangent slope generator. You could simplify this if you want, but like all you need is the equation of the tangent line. So you need to, I don't have to do much work. So plugging in 1, the tangent slope at the point 1, 2 will be 5 times 1 to the 4th times 2 times 2 plus 1 times 1 to the 5th. So this is 20 plus 1, which is 21. I can see there's two 21s right there, so I feel pretty good. So plugging in my information, y minus 2 equals 21, x minus 1. It's all in y equals forms, so I need to distribute. Y minus 2 equals 21x minus 21 plus 2. Y equals 21x minus 19. Notice every single problem I've done so far has involved lots of work, okay? Every single problem you're going to have on your test will involve lots of work. Don't just think you can look and then select an answer. Not up in here. Another equation of a tangent line, y minus y1 equals m times x minus x1 is our goal. The point will, they tell you the point, 0, 1. Yeah, if I plugged in 0 in for x, it's 0 plus cosine of 0, which is 1. So yeah, they help you out there. So you have the 0, 1. So y minus 1 equals m times x minus 0. Yeah, that's an m. Now we just need the tangent slope, which will come from the tangent slope generator with the x-coordinate 0 plugged in. Derivative of x cos x is 1 plus negative sine x. Plugging in 0, I get 1 plus the negative sine of 0. Sine of 0 is 0. So y prime of 0 is 1, which means the slope is 1. So at the point 0, 1, the slope is 1. The slope comes from tangent slope generator. And then solving, you just get x plus 1, which is b. All right, it's a good question. What's the value of h prime of 1? H prime is this. G is 2x plus 1. There's two ways to do this. I'm going to just go ahead and say, well, if g is 2x plus 1, let's plug that in for g. And h of x equals f of 2x plus 1. And then the question is, what is h prime of 1? So I got to take the derivative of h. But it's not a product. This is a composition. So I'm not going to use the product rule to take the derivative of this. I'm going to use my O's and my I's and understand it's a composition. So I got f of is the outside and 2x plus 1 is the inside. Derivative of the outside, f prime. Derivative of the inside, 2. So h prime of x is f prime, whatever starts in the parentheses stays in the parentheses, times 2. And then it's like, all right, I got to find h prime of 1. Okay, how do I find h prime of 1? H prime of 1 equals f prime of 2 times 1 plus 1 is 3 times 2. So I got to find f prime of 3. Well, here's f. And at 1, 2, 3, f prime would be the slope of f at 3. I need to find this slope. You can use rise over run. The slope of the line segment will be the slope of the tangent. I go down 4 over 2. So that slope is negative 2. Down 4 over 2. Rise over run. That slope's negative 2. So negative 2 times 2. My answer is negative 4 right there. Now notice I'm not looking at my answers first. I'm getting the answer, and then I'm looking at the answer choices. This is very, very important. Never try to cross off an answer choice because you're like, oh, that looks wrong. You have no idea what the answer is until you put the work in. So every single question you do starts with doing work, not looking at answers. All right, this is a good test of terminology, understanding that instantaneous rate of change is the same as slope of a tangent, which is the same as the word derivative. So if you ask, like, what is the instantaneous rate of change of f at x equals 3? You're looking for the derivative at x equals 3. The derivative at x equals 3 gives you the instantaneous rate of change. So you're going to use your power rule to find the tangent slope generator. This will generate tangent slopes to f. You don't have to solve this equation, set equal to anything. You're literally just figuring out what is f prime when x is 3. 3 squared is 9 times 3 is 27. 12 times 3 is 36 plus 8. So this is negative 9 plus 8, which is negative 1. Yeah, it's got a little bit of arithmetic there. So practice your mental math, your arithmetic skills to get that answer. 9. All right, we are told the function is differentiable. It's a piecewise function. So this is like the previous problem we did. We need to make sure that this piecewise function is continuous, that there's no jumps, that the first little piece meets up with the second little piece. When we leave one and pick up the other one, which is an x-coordinate of 2, that's the important x-coordinate, giving me the equation 2c plus d equals 4 minus 2c. I have two variables. I can't do anything with that, so I need another equation. The other equation will ensure that there's no sharp points when we do meet up. When there's no sharp points and we meet up, we're continuous and we have a tangent slope. So this is where we take the derivatives and make sure that the tangent slopes of both pieces equal each other. C and D are just numbers, so the derivative of cx plus d is just c. If I had an x, I'd plug in 2 in for it, but I don't, so I just leave it as c. X squared minus cx, its derivative is 2x minus c. I do have an x, so I can plug in 2. And now I'm able to find what c is. C is 2. Once I have c, I'm able to find d. 4 plus d equals 4 minus 4. So d is going to equal negative 4. The question is, what is the value of c plus d? So you literally have to take 2 plus negative 4 and get negative 2, and that's your answer. You'll see a similar question to this on your test. different numbers though. Same question, piecewise function. Got to check to make sure that they meet up. Does my first little piece meet up with the second little piece at -1, which is the important x coordinate, where we stop plugging into one and we start plugging into the other one. I plug in -1 and I get -3 plus 5 equals, okay, -1 squared and then times -1. Like, let's think about order of operations. I need to square things first and then make them negative. So this would be -1 plus 3. This is 2 equals 2. So boom, we are continuous. Now let's check to make sure there's no sharp points. Does the first little's derivative at -1 equal the second's little derivative at -1? First derivative is 3, nothing to plug in, no x's to plug -1 in. Second derivative would be -2x plus 0. If I plug in -1, I get 3 equals 2. This is not true, which means this piecewise function, we will meet up. However, we meet up at a sharp point, which is why we say the derivative does not exist. The answer is E. When are we continuous but not differentiable? That sharp point right there. We are continuous, we connect. This hole, we're not continuous. This jump, we're not continuous. We are continuous here, but that's a sharp point. That means we don't have a tangent slope there. The slope is not 0, the slope's not positive, it's negative, it's different depending on which side you look at. So at the point A, this is the first question that we've done where it involves very minimal work. But it does involve an understanding of a concept. Oh, that's good. If f of x is x, what's f prime of 5? Well, f prime is 1, which means f prime of 5 can't plug in 5 anywhere, so it's just 1. It's a good little question testing you on your derivative and your understanding of what happens when you plug in 5 for x. It's like I can't plug in 5 anywhere, so the slope of y equals x is just 1 everywhere, no matter what x coordinate you look at. All right, this is another situation where we have a product. We need to use the product rule. And then within the product rule, we need to use the chain rule. So we have to do first, second, derivative of the first times the second plus the derivative of the second times the first. This is something that you just know. If you don't know the product rule, you need to learn it. Go ahead and redo the lesson 3 homework and the quiz. Now, when I do the derivative of the first, I got an O and an I. The O is the square. The I is x minus 1. It's actually not that bad. The derivative of the outside is 2 times. The derivative of x minus 1 is just 1. So f prime, derivative of the first, 2 parentheses times 1. I don't need to put that 1 there, but whatever. Whatever started in the parentheses, stay in the parentheses. Times the second, plus the derivative of the second. The derivative of sine is cosine. This has to be known to you. I'm not going to put it up on the board. Times the first. Okay, and now I got to plug in 0. Well, I know this left piece, the sine of 0 is 0, so I know that's going to be 0. Here, the cosine of 0 is 1. 0 minus 1 is -1, but -1 squared is 1. So the slope is 1. Product rule. Y prime is the same as the notation dy dx, derivative of the first times the second, plus the derivative of the second times the first. Reorder things however you want. You can put the x in front of the cos x. Don't multiply this x by this x. And you see it right there. And if you want to reorder things, so x cos x is in front of the sine x, so it's like x cos x plus sine x. Maybe you have to do that, but I can see my answer right there. So that's it. Oh, I remember this problem. All right, this is another product, and within the product is a chain. A lot of you might think it's an outside inside, but it's not. Product rule comes first, and then when we take the derivative of the second piece, we'll have to use the chain rule. All right, so here we go. Derivative of the first piece times the second plus derivative of the second piece. Let's do a little bit of work over here. I'm not going to write the outside as a square root. I'm going to write it as stuff to the 1/2 power. And then the inside, x squared plus 1. Derivative of the inside, easy. Derivative of the outside, remember, fractional powers, still use the power rule. So the derivative of the second piece is 1/2, parentheses to the negative 1/2, times 2x. What starts in the parentheses stays in the parentheses. Don't forget to multiply by the first. All right, this is first prime, second. This is second prime, all of this, and then times the first. Now you can multiply the 1/2, the 2, and the 5x together. And the 1/2 and the 2 is just 1. The 5, the x is 5x squared. You can move this to the denominator, turn that negative 1/2 into a positive 1/2, and maybe rewrite it as a square root if you're comfortable with that. And this is y prime, that's dy dx, and now we have to plug in 3. Now, you see these? Like, maybe we don't have to simplify much. Let's see. 5 times the square root of 10 plus 25 times 5 is 75. Wait, no, it's 125. Yikes. Sorry. Slow down, Mr. Messer. 3 squared is 9 plus 1 is 10. It's 5 times 10, root 10. Here, 3 squared is 9 times 5 is 45. Okay, great example. I got an answer. I feel good about my answer. I look at my answer choices. I hope that I see one. Oh, okay, hold on a second. 45 over root 10 plus 5 root 10. Oh, feel good. Feel good that it's like, oh, there's the answer right there. Maybe on your test, this doesn't happen. Maybe you need to be prepared to simplify things. Maybe you need to rationalize. Maybe. Maybe you need a common denominator. Whatever. So it's like 5 root 10. I can multiply this by 10 over 10. So it's 50 over 10 plus 45 root 10 over 10. Maybe you need to turn this into 95 root 10 over 10. Like, that's another answer. But when you get your answer, look, hopefully you see it, boom, you're done. Don't simplify unless you have to. I didn't have to do all this stuff in red. So my answer's right there. 16. All right, quotient rule, derivative of the top times the bottom minus the derivative of the bottom times the top. Be careful. I'll show you in a second. All over the bottom squared. Change your subtraction into plus a negative. That way you know you're distributing a negative. We're going to have to simplify that. You don't see that answer anywhere, do you? Nope. So I got to simplify this numerator. X squared plus 1 plus. This will be negative 2x squared after I distribute the negative 2x. And this is negative 2x. That's all over the x squared plus 1 squared. That simplifies to be just negative 1x squared minus 2x plus 1 over x squared plus 1 squared. Negative x squared minus 2x plus 1 over x squared plus 1 squared. Boom, that guy, number C. Now, what do you notice? Like, if you don't know your rules and you're just going to like show up and it's like, I'll figure it out. You know, it's multiple choice, no big deal. Maybe you forget that there's a quotient rule. Maybe you take the derivative of the top and divide it by the derivative of the bottom. Look at that guy. That's like one of those misleading answers that will always show up on the AP calculus exam. There's always going to be like the students who don't know what they're doing will probably do this. And when they do this, they get this answer. We'll make sure that answer is on an answer choice. Okay? So know your stuff. Don't look at the answers. Don't let the answers lead you in a direction that is just wrong. This 1 over 2x is just wrong. It is the test makers trying to trick you. So do your work first. Get your answer. Look, be confident in what you do. Know maybe you need to simplify. Now the quotient rule, derivative of the top, in parentheses times the bottom, minus the derivative of the bottom times the top. Careful, careful, we're going to have to distribute that negative. A lot of people don't do that. All over the bottom squared. Yeah, distribute this negative. Distribute this negative. And we're going to have to distribute this because I don't see this answer anywhere, right? So let's do it. 2x times x is 2x squared. 2x times 3 is 6x. 3 times x is 3x. 6x plus 3x is 9x. And then I got minus an x squared, minus a 3x, and minus a 2. I distribute that negative. It's very important. And let's just work on the top one more time. 2x squared and negative x squared is 1x squared. 9x minus 3x is 6x's. 9 minus 2 is 7. So I got x squared plus 6x plus 7 over x plus 3 squared. X squared plus 6x plus 7 over x plus 3 squared. Okay. Quotient rule. All right. What is k prime of 3? K is f over g. Notation matters. F over g, function divided by a function. If you wanted to take the derivative, got to use the quotient rule. This is a table problem that we've been practicing. Derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. At 3, plugging in 3, f prime of 3 is 5. G of 3 is 2. G prime of 3 is negative 2. F of 3 is negative 1 over G of 3, 2 squared. What's that give us? 10 minus a positive 2 over 4. 8 over 4 is 2. Table problem. Use your notation, use your rules. Don't forget about your rules. Too many people do f prime over g prime. Watch what happens. Watch this, watch this, watch this. Just this is a good example. What if you made a mistake? What if you forgot the quotient rule? F prime of 3, 5. G prime of 3, negative 2. Oh, I think it's that. Oh, I feel good about myself. There's the answer. Wrong, 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 wrong. Okay? Know your rules. Use your rules. Don't get misled because, man, you're going to circle an answer feeling good about yourself, but you were wrong. Oh, yeah. Here comes this problem. Okay, this is like our third example of like a product, and within the product is a chain. Okay? It's asking you to find f prime. Maybe you can't read that. So you got the derivative of the first times the second plus the derivative of the second. Now for the second, you need to use the chain rule, your O's and your I's. Derivative of your O, 3 stuff squared, derivative of your I, 2x. So the derivative of the second is this entire derivative. 3 stuff squared times 2x, whatever started inside stays inside. That's the derivative of the second times the first. Okay? Now you look around and you're like, yeah, nothing looks just like that. I must have made a mistake. Nope, you didn't make any mistake. Maybe we multiply the 3 and the 2x together and you get 6x, x squared plus 2 squared, x minus 1. It looks like all of these are products. Okay, so what I'm going to do is try to factor. Now, the way I'm going to show you how to factor is to take x squared plus 2, and I'm going to turn it into a y. I think it helps students when you see that. I might not have done this on your homework video, but I'm doing it now. Okay? And you realize, oh, I could factor out 2y's from this and 2y's from this. They have it in common. So let's factor out y squared. I'm left with a y, and I'm left with 6x, x minus 1 over here. Now, what did I do? I replaced x squared plus 2 with y. So let's go ahead and just re-replace it. This is looking better. X squared plus 2 squared, x squared plus 2 squared. Okay, cool. Well, what else can I do? Maybe I need to distribute this. 6x squared minus 6x. X squared plus 2 plus x squared plus 2 squared. X squared plus 6x squared, 7x squared. So I got that here, and then I got 7x squared minus 6x plus 2. 7x squared minus 2. I got it. Okay. I warned you in the notes, in the homework, on your quiz, you got to be able to do this. You'll see a test question like this. All right, simple chain rule. O and I, fifth power is the O. X cubed minus cos x is the I. Derivative of the O, 5 stuff to the fourth. Derivative of the I, 3x squared. Derivative of cosine is negative sign, so the derivative of negative cosine is positive sign. So y prime would be 5 parentheses fourth times the quantity of 3x squared plus sine x. What starts in the parentheses stays in the parentheses. So I'm hoping I see that there. Okay. Chain rule is an important rule because, like, you have to know the power rule to use the chain rule. You got to know the derivatives of sine and cosine to use the chain rule. So, like, there's probably gonna be a lot of questions on the chain rule on the test because it's testing you on your other rules. What do I do with this? Sine cubed x, I rewrite it as sine x cubed. You want to take the derivative of that? Chain rule. O, I, derivative of the O, derivative of the I. Multiply them together. I haven't shown this, but like that's the chain rule is take the derivatives of the O and the I and then multiply them. So dy dx, which is y prime, 3 stuff squared times cos x. Whatever started in the parentheses, stay in the parentheses. So 3 sine squared times cosine. I know that sine x squared is the same as sine squared. So that's it right there. Chain, tan of 2x, O and I. O is the tangent function, the I is 2x. You need to know the derivative of the tangent. Secant squared. Okay, so f prime is secant squared parentheses times 2. What starts in the parentheses stays in the parentheses. I want to find this at pi over 6. Oh, how do I do that? Secant squared. Okay, 2 times pi over 6 is 2 pi over 6, which turns into pi over 3. Okay, how do I find the secant squared of pi over 3? Well, we first start by doing the secant of pi over 3 squared. Secant is a reciprocal of cosine. We got to think about the cosine of pi over 3. Pi over 3 is 60-degree angle. Cosine, the adjacent. Cosine of pi over 3 is a half. Secant, it's got to be 2 then. I need to take 2, square it, multiply by 2. 2 squared is 4. Times 2 is 8. If you didn't do the chain rule right, maybe you just end up with 4. You forgot about this last 2. Okay? Pay attention to details. Do the work first. Do the work first, then look at the answers. All right, I think we had this in our notes. It is a combination of a chain and a quotient. Now, the chain rule is going to come first because when we take the derivative of the inside, we're going to use the quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. I'm going to simplify this. It's x plus 1 minus x, so that's just going to be 1 over x plus 1 squared. So here's y prime. 5 parentheses fourth times 1 over x plus 1 squared. What starts in the parentheses stays in the parentheses. I look. I don't see that anywhere. Bummer. So we got to simplify. What can I do? Well, you know that like if you have a quotient to a power, it's the same as each individual piece to the power. So I could write this as x to the fourth over x plus 1 to the fourth. It's not x to the fourth, 1 to the fourth. It's the bottom to the fourth. And what I realize is that I have 4 and then 2 more being multiplied together. I have 5x to the fourth over x plus 1 to the sixth. You can't cross out an x with this x because of this addition. Okay? Addition is not simplification's friend. You're done here. This is the simplified version. 5x to the fourth over x plus 1 to the sixth. Get your derivative. You might have to simplify to see your answer. Takes a lot of work. Be confident in what you're doing. All right, it's a table problem. I need to take the derivative of f of g of x. This is not a product. You will not use the product rule. You will say the outside is f, the inside is g of x. It's derivative, I don't have g and then I don't have an outside, middle, inside because the derivative of x is just 1 and because the derivative of g is just g prime. So the derivative of h prime, is the product of these two things. It's f of times g prime of x. This literally is the chain rule. Whatever started in the parentheses stays in the parentheses. And now I want to find h prime of 1. Okay, well, let's just plug in 1 first. All right, now what can I find? G of 1. G of 1 is 2. So watch what happens. This turns into, sorry, this is f prime. Wow, sorry. So g of 1 is 2. That goes right there. G prime of 1 is negative 3. F prime of 2 is needed. I'm not finding f prime of 1. I'm not using that 3 at all. I'm using f prime of 2, which is negative 4. That times negative 3 is positive 12. Another chain, what's the derivative of f? Okay, it's an outside and an inside. The outside is the sign parentheses. The inside is h of x. I don't have to worry about a middle and an inside because the derivative of h of x is just h prime of x. It's nothing fancy. There's no o and I here. The derivative of sine is cosine. So f prime would equal, multiply these two together. That's the chain rule. Cosine parentheses, whatever started in the parentheses stays in the parentheses, times h prime of x. Cos h of x times h prime of x. Okay, do the work, then look at the answers. Home stretch. H of x is 3f of x minus 2g of x minus 5 cos x minus 3. What's h prime of 0? Okay, what's the derivative here? 3f of x derivative, I don't need the product rule because it's a constant times a function. The derivative of 3 sine is just 3 cosine. The derivative of 3f is just 3f prime. The derivative of 2g of x is 2g prime. Notation matters. The derivative of negative 5 cos would be positive 5 sine. The derivative of cosine is negative sine. The derivative of negative cosine would be positive sine. The derivative of 3 is 0. I'm going to put 0 there just so you know. Don't forget the derivative of 3 is 0. H prime of 0 would be 3f prime 0 minus 2g prime 0 plus 5 sine 0. F prime of 0 is 3, so I got 3 times 3. G prime of 0 is 7. I got 2 times 7. Sine of 0 is 0. We know this. We know this. 9 minus 14, negative 5. Then look at your answers. Derivative of cotangent. Do you remember? I don't remember. What am I going to do? All right, well, maybe you remember. Maybe you rewrite. Cotangent's cosine over sine, right? Take the derivative. Derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Negative sine squared minus cosine squared over sine squared. Many of you will try to cancel that. You can't. But what you can do is factor out a -1. Realize you have sine squared minus plus cosine squared, which is just 1. It's the Pythagorean theorem in the unit circle. This turns into just -1 over sine squared. Sine's reciprocal is cosecant. You either remember that or you could figure it out. What do you want to do? You want to do this? You want to do that? You can do it. I probably want to just remember it. Tangents, derivative is secant squared. Cotangent's going to be similar. It's going to be negative, and it's going to be like the flip, kind of. Instead of secant squared, it's cosecant squared, but negative. G prime. What's this? It's not a chain. This is a product. It's another table problem, though. Derivative rules. Derivative of the first times the second plus the derivative of the second times the first. Plug in 3. 2 times 3 is 6. F of 3, I'll write down. F prime of 3. 3 squared is 9. Plugging in 3 for x. F of 3 is 4. F prime of 3 is 5. Oh, thanks for the big number, guys. 24 plus 45. 69. All right. 29. Oh, another table problem. H prime of 3. It's a product. Use the product rule. If you don't use the product rule and you just write by F prime G prime, you're gonna get an answer. The answer will be provided. Okay? So you got to know what you're doing, or you're gonna be misled. The derivative of the first times the second plus the derivative of the second times the first. Plugging in 3. F prime of 3, which is the slope of the tangent to F of 3. G of 3, which is the y coordinate of G at 3. G prime of 3, slope of the tangent to G at 3. F of 3. So I'm focusing my attention at 3. Let's look at the y coordinates first. Oh, this is tricky. F is this one. So F of 3 is 4. G of 3 is 3. G prime of 3 is the slope of this tangent, which is the slope of the line segment. Use rise over run. Up 2 over 1, that's 2. F prime, down 1 over 1. The slope of that line segment is going to be -1. So I get -3 plus 8, so 5. Right? That's what you got to do. Get your answers first. Another table problem. G prime of 9, F over root x, so quotient rule. Derivative of the top times the bottom minus the derivative of the bottom. How do you take the derivative of the square root of x? It's x to the 1/2. You don't have to write it like that. X to the 1/2. So it's 1/2 x to the -1/2. That's the derivative of the bottom times the top. All over the bottom squared. Root x squared. Root x squared is just x. Plugging in 9. F prime 9 times square root of 9, 3. Just positive 3. This can be written as 1 over 2 root x, so minus 1 over 6 times f of 9 over 9. Great. Great. All right. Where's my space? Over here. F prime of 9 is 7, so I got 7 times 3 minus 1/6. Thank you. F of 9 is 18. I say thank you, so that 18 times a 6 is just 3. I don't have a fraction inside of a fraction. Over 9. So I get 21 minus 3 over 9. So 21, 20, 19, 18 over 9. 2! Isn't that great? Such a simple answer from such a crazy problem. Do your work. Get your answer. Table problems. Gosh, I'm really throwing these table problems at you because a lot of students really have problems with this. This is the quiz that we had a group quiz on. So you know it or you don't, right? All right. Derivative of the top, 4f prime, times the bottom, minus derivative of the bottom. Derivative of g of x plus 1 is just g prime of x time plus 0. Derivative of 1 is 0. Times the top. These are just like fun little puzzle problems, you know? all of math are puzzles, but these especially, just like testing you over the bottom squared. All right, h prime of 2. I'm just going to write the numbers here. F prime of 2 is a half. Thanks, guys. G of 2 is negative 3. It's not going to be that bad. G prime of 2 is 2 times 4. F of 2 is negative 3. Great. G of 2 is negative 3 plus 1 squared. Let's finish it up over here. This will be 2 times negative 2 minus 8 times negative 3, which is negative 24. So this will be plus 24 over 4. Negative 4 plus 24 over 4. 20 over 4. 5! Many of you, when you did the group quiz, realized, like, what are you bad at? Arithmetic. Like keeping track of numbers, keeping organized. It's stuff that you have to practice. Don't just get here and then make a mistake and be like, oh, I won't make that mistake again. If you get here and then you can't get the right answer, you need to practice your arithmetic. You need to practice your order of operations, understanding of minus and negative, keeping track of signs must be practiced. Okay. Even I make mistakes on that stuff. Like you got to pay attention to details. I might have made a mistake right here. I don't know. I don't think so. Okay, what's the average rate of change over the interval from negative 2 to 2? I'm going to add one more question to this, okay? Average rate of change is the slope of the secant, right? y2 minus y1 over x2 minus x1 was how you do it. Okay, great. What if I asked you to approximate the instantaneous rate of change at x equals 1.5? What would you do? This brings us back to our first lesson of how tangent slopes really just start from a slope formula, y2 minus y1. It's just you take 2 points really, really close together. The closer you get your points together, the better approximation you get. Better and better approximations turn into actuals. So if I asked you, what's the derivative at 1.5? You're like, well, I can't find it, but I can approximate it. Because I realize this point here, 1, 0, and 2, 5, that's surrounding the point at 1.5. Those are 2 points close to the x coordinate 1.5. So I would use those 2 points in my slope formula. Instantaneous rate of change at x equals 1.5 is approximately y2 minus y1 over x2 minus x1, 5. There's a question on your test where it's like, here's a table. What would be your best approximation for a tangent slope? And the point's going to be in between 2 points. Use the 2 points closest to that point. Okay, the slope. Getting 2 points as close as you can based on the information you have. That's all you can do. That's the best you can do. So that's it. All right. This is the minimum that you do. The minimum that you do. If you're going to do anything again, do that unit 2 quiz, the lesson 2 quiz. That gives you slopes of tangents equal horizontal tangent locations. You're going to have horizontal tangent locations. You don't have it on this. It didn't show up on this. Horizontal tangents didn't show up on this. It'll show up on your test. That's from quiz 2. When are we having parallel tangents? That didn't show up on this. It'll show up on your lesson 3, the quotient rule. You're going to have a quotient rule problem like questions 4, 5, and 6 on your lesson 3 quiz. You don't see that on this. Okay, this is just random examples of types of problems. These are not the exact problems you're going to see. So you need to be prepared for those. So you've done these, great. You need to go back and do, at minimum, your lesson 1 quiz, graphing f prime. You didn't see any graphing f primes, it's going to show up on your test. Parallel tangents, horizontal tangents, those types of questions didn't show up here, it'll show up on your test. When do we have tangents that are parallel to, but you're using the quotient rule? It'll show up on your test. We did a good job practicing table problems. We did a good job practicing chain rule on this. But those types of questions from lesson 1, sketching F prime, from lesson 2, parallel slopes, horizontal tangent locations, lesson 3, parallel and horizontal tangents using a quotient rule, that's showing up on your test. So I hope you're watching this video, not just copying things down because it doesn't help you. And good luck on your test.